Hello everyone, in this video we go over questions 37 to 44. The answer to question number 37 is E. The question asks you about the forces acting on A. Now in the x direction there are no forces acting on A. There are forces in the y direction, like the normal force and the weight of A, but there are no forces on the x direction. So the answer is E. Now if the question is about the forces acting on B, you can see there is 100 Newton acting on B. So if you draw the force body diagram here and we look at the forces in the x direction, there is the 100 Newton in the positive x. Also the question tells you that the object is moving with a constant velocity. Constant velocity means the acceleration is 0, and hence there should be an opposite force, which is basically the force of friction, acting on the object in the opposite direction that causes it to have 0 acceleration. And since we know that the sum of the forces in the x direction will be the mass of the object, in that case object B, times its acceleration. Now the sum of the forces will be the 100 Newton in the positive x minus the friction. This is equal to the mass times the acceleration, and since the acceleration is 0, so the left hand side of the equation is 0, which means that the friction should be equal to 100 Newton, and this should be of course in the opposite direction. So we have 100 Newton here of friction force. Hence the answer is B. In question number 39, the answer is D. Now notice here the forces acting on the weight W. We have P, and P is directed downward with an angle of theta. And there is also the weight of the force and the normal force. So now if we draw the force body diagram, where the object will be in the center, we have the normal force upward, we have the weight downward, this is in the y direction. Now the force P here can be resolved into two components. The x component, which will be P cosine the angle theta, since the x component here is the adjacent to the angle, while the y component of P, so this is P sub x, while P sub y, the y component of P is opposite to the angle, so it is P sine theta. So now the y component of P, the vertical component of P, which should be P sine theta. And the friction is always opposing the external force, and of course the friction is always parallel to the surface, the two surfaces, the interface between the two surfaces. So the friction is in the opposite direction to P sub x here, the force of friction, F sub F. So basically the force of friction will be in this direction, okay? So basically we have three forces in the y direction. Normal force upward, while the weight and the y component of P downward. And we have two forces in the x direction. We have the friction in the positive x, and we have P cosine theta in the negative x. Now in this question we are asked to find the normal force, or the formula of the normal force. So we are going to focus on the y direction. So we apply Newton's law in the y direction. The sum of the forces in the y direction is equal to the mass of the object times the acceleration in the y direction. Now since the object is moving across the floor, hence its acceleration in the y direction is 0. So we'll go ahead and apply the left hand side of the equation. The sum of the force in the y direction is 0. We have the normal force in the positive y, and then we have P sine theta and the weight in the negative y. So this is minus P sine theta minus the weight equal to 0, which means that the normal force is equal P sine theta plus the weight. And this is basically answer D, W plus P sine theta, or P sine theta plus W. Okay, in question 40, the answer is E. Note here in this question we need to find the relationship between P, T1 and T2. We are given the weight of each box, and we are told that there is a force P applied on them, and there is tension T1 between the 10 Newton and the 20 Newton weight, and then a force T2, which is a tension force between, which is also a tension force between the 20 Newton and the 100 Newton. And an important point here is that those weights are laying on a frictionless floor, so there is no force of friction here. So taking that into consideration, if we apply Newton's law on the compound that include the combination of those three masses, we have only one force acting on them, which is P. If we find the mass for each one of those weights, we know that the force of gravity is m times g, which means M is the weight, the force due to gravity, which is the weight, divided by G. If we take G to be 10 meters per second square, just for simplicity here, take G to be 10 meters per second square, so the mass of the 10 Newton will be 10 Newton divided by 10, which will be 1 kilogram. The second object will be 2 kilogram, and the third object will be 10 kilogram. So if we go ahead and apply Newton's law on the compound here, so apply the sum of the forces in the x direction equal to the three masses, 1 plus 2 plus 10 kilogram. This is times the acceleration, which will be in that direction, in the direction of P. And the forces here in the x direction will be only one force, P, in the positive x, equal to the 13 kilogram times the acceleration. So we can see here the acceleration will have a value. The acceleration is actually P over 13 kilograms. So the system is moving with an acceleration. Now if you apply Newton's law on each individual object in order to be able to compare P to T1 to T2, so go ahead and apply Newton's law in the x direction on the first mass, the 1 kilogram times A. You have two forces. You have P on the positive x direction minus T1 in the negative x equal to 1 kilogram times A. So this will tell us that P is bigger than T1. Basically P is equal T1 plus 1 kilogram times A. Okay, so we have this equation 1. Apply Newton's law on the second mass, the sum of the forces in the x direction equal to the 2 kilogram times the acceleration. And here the forces that are acting on the 20 Newton weight in the x direction are two forces. You have T1 in the positive x, as you see here, T1 in the positive x, and you have T2 in the negative x. So it's T1 minus T2 equal to 2 kilogram times A. T1 is bigger than T2. T1 will be equal to, if you move T2 to the other side, it will be T2 plus 2 kilogram times A, and A is a positive value. It's moving in the positive direction. We can see here that T1 is bigger than T2. Now if you apply Newton's law on the third weight, the 100 Newton, we have only one force acting on it, which is T2. This is action and reaction forces. So T2 here is the same as T2 that is applied on the 20 Newton. So now apply Newton's law on the 100 Newton weight, which is 10 kilogram mass A. And this basically, the left hand side will be T2 in the positive x. There's no other forces acting on it, there is no friction, equal to 10 kilogram times the acceleration. Okay, so this is all the relationship we can get. This is 1, this is 2, and this is 3. Now let's look at all the choices here. Choice A tells you that T1 is equal to P. Now we can see here clearly that P is bigger than T1, because P is equal to T1 plus 1 kilogram times A, and A of course is positive and it has a value. We can tell that A has a value from this formula. A is not 0, it has a value which is the force P divided by 13 kilogram. So this choice is wrong. It's clearly that P is bigger than T1. Now let's look at choice B. Choice B tells you that T2 is equal to P. Now this is clearly not true, because from formula 1 we can see that P is bigger than T1, and from formula 2 we can see that T1 is bigger than T2. So if P is bigger than T1 and T1 is bigger than T2, then necessarily P is bigger than T2. Hence choice B is wrong. Choice C tells us that T1 plus T2 equal to P. Now this is wrong. Why? Because if you look at equation 1 and equation 3, equation 1 tells us that P is equal to T1 plus 1 kilogram times A. So in order for P to be equal to T1 plus T2, T2 has to be equal to 1 kilogram times A. But we found from equation 3 that T2 is equal to 10 kilograms times A. So it's not 1 kilogram times A. Hence, this choice is wrong. Choice D tells us that T2 is bigger than T1. And this is of course not true, because we found that T1 is bigger than T2. Hence, D is wrong. And the only choice that is valid is E. T1 is bigger than T2, which we proved here. Okay, on question number 41, The answer is D, assuming we are rounding off the answer to 3 figures. So a 400 kilogram box is lifted vertically upward with constant velocity, so the velocity is constant, which means that the acceleration is 0. The acceleration in the y direction is 0. Now it's lifted upward with constant velocity by means of 2 cables pulling at 40 degrees on either side of the vertical direction. So if we draw the tension forces here, there is tension force in this direction and there is tension force in this direction, and the angle with the vertical is 40 degrees. This angle here is 40 degrees, and of course there is the weight downward, which is 400 kilogram times 9.8 meter per second square, which will yield 3,920 Newton. This is the force downward. Okay, so the question is, what is the tension in each cable? Assuming that the tension is the same. Of course, the tension here, we can prove that it's the same if we apply Newton's law in the x direction. T cosine 40 in the positive x and T cosine 40 in the negative x, the sum of them will be equal to 0 since there is no acceleration in the x direction, which means they balance each other, so the tension has to be equal. But now here we are asked to find the tension, so we have to apply Newton's law on the y direction. So the sum of the forces in the y direction would be equal to the mass times the acceleration in the y direction. Now here the acceleration is 0 because the velocity is constant. So now if we go ahead and look at the forces in the y direction, and to do that we'll go ahead and draw the force body diagram, assuming the mass here is in the origin. So here in the y direction we have 3 forces. We have the weight downward, and that's the 3,920 Newton, which we evaluated by multiplying the mass in kilogram by the acceleration due to gravity. And then we have the 2 forces of tension. Now notice here the y component of the tension will be the adjacent to the angle. So this is the y component here, and the same thing for this one. Y component will be here. It will be T cosine 40. It's adjacent to the angle because here the angle, the 40 degrees, is with the vertical direction. So be careful about that by observing which angle we are talking about. If it's adjacent, it will be the force times cosine the angle. If it's opposite, then it will be the force times sine the angle. So here upward you'll have T cosine 40 degrees, or you can take it T sine 50 because this angle will be 50 and the y component will be opposite to the 50, so it will be T sine 50, and sine 50 degrees is the same as cosine 40 degrees. Cosine 40 degrees or T sine 50 degrees, up to you. So those are the forces in the y direction. So if we go ahead and plug them into the equation, we have T cosine 40 plus T cosine 40, which is 2 T cosine 40, minus the weight, since the weight is in the negative y. This is equal to the mass times the acceleration, which is 0. Therefore, 2t cosine 40 degrees is equal, we move 3,920 to the other side, Newton, and then we solve for t. So t is equal to 3,920 Newton divided by 2 times cosine 40 degrees. And this will give you, now cosine 40 is around 0.7 something times 2, which will be 1.532. So it's around 3,920 Newton divided by 1.53, and this should give you around 2,562 Newton. When you round it off to 3 figures, this is 2,560 Newton, which is D. The answer to question number 42 is C. So here we need to find the force by which the mover is pulling down on the rope. Now this force is equal to the tension on this rope, which equal to this tension as well, equal to, of course, the tension here, because they are all representing the same rope wrapped around a frictionless massless pulley. And this will be also the same tension here, which is the same tension here, action and reaction. The rope is massless, so the tension here is the same as the tension here, equal to the tension here as well. And of course this is the pull, action and reaction. So there are two forces acting on the piano upward, this tension and this tension, the two tensions. And there is the weight of the piano downward, the 1000 Newton. So if you draw the force body diagram on the piano, you have the tension upward, two forces of tension upward, and the weight of the piano downward, 1000 Newton downward. Now note that the piano is raised at a constant speed. This implies that the acceleration is 0. So now if you apply Newton's law in the y direction on the piano, which is the mass times the acceleration of the piano in the y direction, and since the acceleration is 0, then this part is 0, and the forces in the y direction are t plus t, which is 2t in the positive y, minus the weight in the negative y, equal to the mass times acceleration, which is 0, which means that the tension is basically equal to 1/2 1000 Newton, which is 500 Newton. And since the tension is equal to the force by which the mover is pulling, hence the force is 500 Newton downward. So the answer is C. Okay, the answer to question number 43 is A. Now if you look at this problem, the force is acting on the mass here on this junction. We have the tension on this side rope, which is 38 Newton, and then we have the tension on this other rope, and both of those ropes are massless, hence the tension is the same everywhere, and this force here is 59 Newton. Now the angle with the ceiling is theta, which should be the same as this angle here, and the question is, what is this angle? Okay, and we have of course downward here the weight of the object. Of course the tension is the same as the weight. So now if you look at the force body diagram, in the x direction we have the 38 Newton in the positive x, and then we have the x component of the 59 Newton. This will be the adjacent to the angle here, so it will be 59 cosine theta. In the y direction we have two forces as well, the weight of this mass, and we have the y component of the 59 Newton, which would be 59 sine theta. So two forces in the y direction and two forces in the x direction. And in all those cases, the acceleration is 0. So the acceleration in the x direction is 0, and the acceleration in the y direction is 0. So you can see here in the y direction, we have two unknowns, the angle and the mass. While in the x direction, we have one unknown, which is the angle, and we are asked to find the angle. So we'll go ahead and apply Newton's law on the x direction. So the sum of the forces in the x direction equal 0, because the acceleration is 0. And now we plug the values. We have positive 38 Newton, this is the positive x, and the 59 cosine theta in the negative x is equal to 0. And now we solve for cosine theta. So if you move that to the other side here, we have 38 Newton equal to 59 cosine theta, which means that cosine the angle theta is equal to 38 Newton divided by 59 Newton. Of course this is 59 Newton, which means that the angle is cosine inverse of 38 Newton over 59 Newton. Now if you carry out the calculation, make sure your calculator is set at degrees. You take cosine inverse of 38 over 59, and Newton will cancel out, of course, and this will give you 49.9 degrees, which is 50 degrees if you take it to two figures. So the answer is A. Okay, in question number 44, The answer is A. Now in this problem we're asked to find the mass m here. So if you look at this mass, we have two forces acting on it, and since we are told that the 100 kilogram is falling, this means that the acceleration is upward. So now if we apply Newton's law in the y direction on m, the equation will be, the left hand side of the equation will be positive t minus mg equal to ma. Okay, and you can see we cannot solve for m here because t is unknown and a is unknown. Of course g is 9.8, so we don't have problem with g, but we have three unknowns actually: the mass, the tension, and the acceleration. So let's go ahead and look at the other mass here, the 100 kilogram. And let's look at the forces acting on it. We have, again, the same tension here upward, which is equal to this tension, since the rope is massless and the pulley is frictionless. And we have the weight downward, which is 100 kilogram times 9.8. So basically it will be 98 Newton. Okay, this is came from mg, which is 100 kilogram times 9.8 meter per second square, which will yield 98 Newton. That's the weight of the 100 kilogram mass. Okay, now let's go ahead and apply Newton's law on the 100 kilogram. So we have equation number 1 here. In equation number 2, we'll apply the sum of the forces in the y direction equal to the 100 kilogram times A. And now here A is downward. This one is falling. This mass is moving up, so the 100 kilogram is moving down. Okay, and the forces in the y direction here on the 100 kilogram is the tension in the positive y minus 98 Newton equal to the mass times the acceleration, and here the acceleration is negative. Again, taking positive y to be upward, negative y will be downward. In this equation we have two unknowns. So the tension here is unknown and the acceleration is unknown. So this is equation number 2, and we cannot still solve for the tension or the acceleration. So what should we do? We have other information given here. We are told that the 100 kilogram is released from rest. So this indicates that the initial velocity is 0. And also we are given the height, which will be the displacement, the 100 kilogram will fall, and the time. So we can apply the kinematics equation on the 100 kilogram, and this will enable us to solve for the acceleration. Now notice here that the 100 kilogram is not on a state of free falling because there is a tension upward. So gravity is not the only factor acting on the 100 kilogram or the individual mass m here for that matter. Now if you look at the information we are given, the block was released from rest, so its initial velocity in the y direction is 0. We are told that its height is 1 meter, so basically its displacement y minus y0 will be negative 1 meter. It will fall downward here. Displacement of negative 1 meter. Negative because it's in the negative direction, taking upward to be positive and downward to be negative. And also we are given the time, which is 0.53 seconds, and the unknown is the acceleration. Again, the acceleration is not g because this is not a free falling problem. The final velocity is not given. So since the final velocity is not given, the only equation we can use is equation number 4. Y minus y0 is equal the initial velocity in the y direction times t plus 1/2 at squared. And now we solve for the acceleration. The initial velocity is 0, so this part will be 0. And the equation will be y minus y0 is equal to 1/2 at squared. Plug the values. Y minus y0 is negative 1 meter. This is equal to 1/2 times the acceleration times t squared, which is 0.53 seconds squared. We solve for a. A will be 2 times -1 meter over 0.53 seconds squared. And this will yield -2 divided by 0.53 squared. This will give you around -7.11997, which can be rounded off to -7.12 meter per second squared. And we got negative values, so that's what we expect. Acceleration is negative. So now we'll go ahead and take it and plug it into equation number 2 and solve for the tension. So if we do that, the tension will be equal to 98 Newton plus 100 times -a, 100 kilogram times negative, that's 7.2, is 7.2 basically, meter per second square. This is of course the magnitude of the acceleration, and the sign is already negative. So this is 98 Newton minus 712. So the tension would be 100 Newton minus 712, which will give you 268 Newton. So now we found the tension. Again, we are going in the opposite direction now. And now we go back to equation number 1 to solve for the mass. Okay, on equation number 1, we have the tension now, and we have the acceleration, so we can solve for the mass. The tension is 268 Newton minus the mass times g, which is 9.8 meter per second square, equal to the mass times the acceleration, and the acceleration is positive in that case, because here the acceleration is moving in the positive direction, positive y direction. So it's the mass times 7.12 meter per second square. Okay, and we solve for the mass. So if you move mass to the other side, you'll have 9.8 plus 7.112, and this will give you 16.92 meter per second squared. So you have 268 Newton equal to 16.92 meter per second squared times the mass, meaning the mass is equal to 268 Newton divided by 16.92 meter per second square. And we know that Newton is kilogram meter over second square, so meter over second square will cancel out, and the answer will be in kilogram, and this will yield around 15.84 kilogram, which is, when bounded to two figures, is 16 kilograms.